Hello, everyone. So this video is all about a little bit of strategy review. The strategy that I'm going to go over is the simplify strategy. And I'm basically taking all of the questions from the official SAT Test 1 that's completely free to download online. So I've gone through that entire test and chosen each question that utilizes the strategy that I call simplify. So on the pages after following this and the rest of this video, we will quickly go through each question using the simplify strategy. So what is the simplify strategy? First of all, every strategy that I teach starts off with understanding how to identify what a question is, right? So how to identify which strategy is useful for a particular question. So for the simplify strategy, each simplify question from a identification standpoint will be short, somewhere between 1 and 3 lines long, and will contain either an expression or an equation that can be simplified. Okay, so that's how you know. So as soon as I open up a test or a practice book, I don't even have to read the entire question. If I see that it's short and I see an equation or I see an expression, my mind immediately tells me, okay, this is the simplify strategy that's going to be useful for this question. So that's how you identify it. The second step, obviously, is, well, why do I call it the simplify strategy? Because we're going to simplify that expression or simplify that equation that's been provided to us in the question. In essence, without even needing to read the question, because I've already identified what type of question it is, I know that my first order of business is to simplify the expression provided to me and or the equation provided to me. After I do that, then I read the question to make sure that I've answered it as it's been asked, and then I move forward on to the next question. So let's get to the sample questions here again. These are all of the questions that I'm saying would require, not require, strategies are never required. All of the questions from the test in which you can use the simplify strategy on. So our first question here, number 1, we can see that it's a single line, right? So that's short. And we can see that it contains an equation. X minus 1 over 3 is equal to k. Now the challenge with x minus 1 over 3 equals k is that we cannot simplify it because we don't know what k is. But the question tells us that k is 3. So once we fill in the information provided by the question, we can now simplify. I simplify by multiplying both sides by 3. My 3's are now gone. I'm left with x minus 1 equals 9. I can add 1 to both sides, and I get x equals 10. I go back just to make sure that's what the question asked me to find. What is the value of x? Yep, x is 10, and therefore the answer is choice D. The next question, again, we see that it's short, and in this case, we have an expression. So I'm going to take that expression, 7 plus 3i plus negative 8 plus 9i. Again, because I already know this is a simplified question, I'm going to get straight to simplifying. So I have like terms. I have 7, and I have minus 8. 7 minus 8 is negative 1. I have 3i, and I have positive 9i. 3i plus 9i is 12i. So there's my simplified version. I go to the question. It says for I equals square root negative 1. What is the sum of this? Well, I already did that. That answer is negative 1 plus 12i, and therefore my answer here is choice A. The next question, again, very short, 2 lines, really only a line and a half, and we have, again, another expression. So I'm going to, again, rewrite this. So in fact, I won't rewrite it because it's so long, but let's see. I have an x squared y here. I have a negative x squared y here, but I have a negative sign that's going to get distributed across here, right? So in essence, this negative will become a positive, this positive will become a negative, and this negative will become a positive after distribution. So I have a positive x squared y plus x squared y. Well, that gives me 2x squared y, right? So I've taken care of those like terms. Then I have a minus 3y squared, and I have a positive 3y squared. Well, those are going to cancel out. Negative 3y squared crosses out with positive 3y squared. And then I have a positive 5xy squared and a negative 3xy squared. So 5xy squared minus 3xy squared is positive 2xy squared. That is the simplified version of the expression we were given. The question says, which of the following is equivalent to the expression above? Well, I've already found that. Again, that's the value of using the simplify strategy. Typically, once you simplify, you've already done what's been asked. So let's look for the answer, and we can see that the answer is choice C. Moving on, again, right, short question, and we have an expression here. We also have an equation here, right, so we have both technically in this question. So we know that A over B is equal to 2. The question wants to know what is 4B over A, and there's nothing I can do to necessarily simplify this. The question wants 4B over A. I can see that A over B is 2. I want B over A here. So if A over B is 2, that means B over A must equal 1 over 2, right? Because, again, this is like 2 over 1, and I'm just flipping them over. A over B is 2 over 1, so B over A is 1 over 2. So if that's the case, then I can say, well, this is 4 times 1 over 2, right? Because B over A is 1 over 2. So 4 times 1 over 2 is equal to, these cancel, making it 2. 2 times 1 is 2, so my answer here is 2. It just asks for what the value of that is, so yes, choice C would be the correct answer to that question. And you can start to see how easy these become when you automatically know what to do as soon as you see them. So this question, I hesitated to put it in because there is actually a different strategy that I would prefer to use, but it does still fit the simplify strategy. It is a short question. It's a single line. We're told a little bit of information about x, right? We know that x is greater than 3. And then we just have which of the following is equivalent to this big expression here. So how do I simplify that expression? Well, I'm going to start with the numerator, right? So the numerator says 1 over x plus 2 plus 1 over x plus 3. Well, in order to add fractions, if you remember from school, you must have a common denominator. And anytime your denominators are different, the easiest way to find a common denominator may not be the lowest common denominator, but the easiest way to find a common denominator is to multiply each fraction by the denominator of the other fraction. So for instance, I'm multiplying the fraction 1 over x plus 2 by this denominator over here, right, x plus 3. And I'm going to multiply 1 over x plus 3 by this denominator over here, x plus 2. And in doing so, I end up with x plus 3 over x plus 3 times x plus 2 plus, and then on the numerator here, I'd have x plus 2 over x plus 3 times x plus 2. And as you can see, now I have a common denominator. So to combine these two together, I end up with x plus 3 plus x plus 2, all in my numerator, and I just have the single denominator of x plus 3 times x plus 2. I can simplify this further, right? I have x plus x, which is 2x. I have 3 plus 2, which is 5. So this becomes 2x plus 5 over x plus 3 times x plus 2. But let's not forget, we started off with the denominator, which means really this entire thing is still in the denominator. So I still have a 1 over 2x plus 5 over x plus 3 times x plus 2. So there's more to do here, right? Because I can just flip this over and say, well, 1 over this is the same as just having x plus 3, and I'll explain why this is the case in a second, x plus 3 times x plus 2 over 2x plus 5, okay? So then I don't see that as an answer, but what I do see is I do see a 2x plus 5 in the denominator for choice B, which means I'm pretty certain that's the right answer. And it just looks like I need to simplify or expand the binomials to get my x squared plus 5x plus 6. Let's just confirm that that's the case. X times x is x squared. X times 2 is 2x. 3 times x is 3x. And 3 times 2 is positive 6, and that does in fact look exactly like I want because 2x was 3x becomes 5x, right? So for sure choice B is the correct answer. So just so that you know, if I ever have so this is kind of a side note, 1 over A over B is going to be equal to B over A, okay? So I'm not going to actually go through all the math on why that's the case. If you want me to, just leave a comment and maybe I'll make a special video on reciprocal fractions, but otherwise, this is the process basically that I used over here, right, to get from there to here. Okay, so there's our answer, choice B. The next question, again, we see that it's short and it has an equation. So this question says if 3x minus y equals 12, what is the value of that? So again, this is not necessarily a very straightforward simplified question, but we know that 3x minus y equals 12. So we do know that. And we know that, and here's where things are not so straightforward. I love this question because really there's another strategy at play here. Which is, and honestly, I'll throw this into the simplified method. So, to simplify an expression, 8 to the x over 2 to the y, anytime you have a fraction with exponents and the base values are not the same, you want to do whatever you can to make them the same, right? So I'm going to actually turn this 8 into a 2 to the third power. In doing so, now my base is 2 for both my numerator and my denominator. So this becomes, when I simplify this even further, just 2 to the 3x over 2 to the y. Now, to simplify that even further, oops, not 2 times y, 2 to the y, don't make that mistake. To simplify this even further, whenever you have fractional exponents, with the same base, you keep the base and you subtract the exponent, so 2 to the 3x minus y. And what do we know? 3x minus y, we know that that's equal to 12. The question tells us that that's equal to 12, which means this entire thing just becomes 2 to the 12th, right? So quite a bit of simplification, a little bit different than we see in the other questions, but nonetheless, this is a worthwhile simplification process to understand whenever you're dealing with variables in an exponent. So here our answer is choice A. The next question, again, single line, t is greater than 0, so we know it's not negative. I have t squared minus 4 equals 0. Well, I can simplify that, right? This is an equation. This is a difference of two squares. T squared minus 4 is the same as t minus 2 times t plus 2, right? So that's going to equal 0. And then I just set each of these individually equal to 0. In order to find my possible t values. And for this one, I add 2 to both sides, and I get t equals positive 2. And for this one, I subtract 2 from both sides, and I get t equals negative 2. But don't forget, the question told us that t is greater than 0, so it cannot be negative 2. And therefore, here's my correct answer. T is equal to 2, and 2 would be the correct answer here. The next question, a equals 5 root 2, and 2a equals square root of 2x. Again, these are technically equations. This one, 2a equals root 2x, can actually be simplified, right? Because I can divide both sides by 2 in order to solve for a, so root 2x over 2. And doing that actually is very helpful because this equation has a equals 5 root 2. And now that I know that a is root 2x over 2, I can rewrite this as root 2x over 2 is equal to 5 square root 2. And now when I multiply both sides by 2, right, to start simplifying this, I get the square root of 2x equals 10 root 2, right, because this 2 gets multiplied by the 5. So get 10 root 2. And then whenever I have a square root, if I want to simplify it, I'm going to raise it to the second power. So I have to raise this whole thing to the second power as well. And I end up with 2x equals, now 10 squared is 100, and root 2 squared is just 2. This becomes 2x equals 200. And then we divide both sides by 2, and we get that x is 100. So quite a bit of simplification, starting off with some simplification which leads into substitution, right? So sometimes we link up different processes in math. Our next question here from test 1, if 16 plus 4x is 10 more than 14. So this is a little bit of translation, right? We have to create our own equation. But again, this is a short question, and this is going to turn into an equation. So I'm going to have 16 plus 4x is means equals. 10 more than 14 just means 24. So I'm going to just write 24. What is the value of 8x, right? So that's what I'm trying to find, 8x equals. So here's where I'm going to do all my simplification. I subtract 16 from both sides. I end up with 4x equals 8. I have x equals 2 after dividing both sides by 4. Don't get fooled and choose choice A because the question does not ask for the value of x. It asks for the value of 8x. And since x is 2, we know that 8x is 8 times 2, which is 16. And therefore, our answer is choice C. And getting towards the end here, again, pay attention to the fact that each of these have been single line or line and a half, 2 lines max, and they have an equation and or an expression. Again, here is our equation. We have the absolute value of n minus 1 plus 1 is equal to 0. To simplify this, I will subtract 1 from both sides, having absolute value of n minus 1 is equal to negative 1. And here's where we have a problem, right? So if you recall, the whole purpose of the absolute value is to turn the value within, right? So in this case, n minus 1, into a positive value, which means there is no way I can ever find any n value that will ever make the absolute value of n minus 1 equal to negative 1. It will always be a positive value because that's what absolute value does. End of story. The answer is choice D. There really isn't any further to go. However, we still did kind of use some simplification, right? Moving the negative 1 over to even figure that out in the first place. The next question, which of the following numbers is not a solution of the inequality? Again, short question. We have an inequality, but still, it's an equation. It's still in the same family of equation. So I'm going to write this down, 3x minus 5 greater than or equal to 4x minus 3. And I'm going to put my x's on the left and my numbers on the right. So I'm going to subtract 4x from both sides, leaving me with negative x minus 5 is greater than or equal to, this is gone, negative 3. I'm going to now add 5 to both sides, leaving me with that's gone. So I have negative x is greater than or equal to positive 2. And now I'm going to actually, let's just say, multiply the entire thing by negative 1, making this a positive x. And then don't forget, whenever you multiply an inequality by a negative number, you're going to flip the inequality symbol. So this goes from being greater than or equal to less than or equal to, and this becomes negative 2. So x is anything less than or equal to negative 2. So which of the following numbers is not a solution of the inequality? Well, negative 1 is not. Right? Because negative 1 is greater than negative 2. And we only want numbers that are less, right? Negative 2 is equal to negative 2, so that works. Negative 3 is less than, so that works. Negative 5 is less than negative 2, so that works. This is the only one that is not a solution. And the last question from test 1 that utilizes this strategy simplification. Again, for the very last time, this is a very short question. We see technically an equation, but we can look at it as an expression. For what value of x is the function h above undefined? So, we need to understand, well, what does it mean? How does a fraction, right? Because h is this fraction here. How does a fraction become undefined? Well, the only way a fraction is undefined is if you are dividing whatever. I'm just putting a hashtag number symbol here for saying anything can be here. Whatever variables, numbers, exponents, doesn't matter. But if the denominator is equal to 0, the entire thing is undefined. So in essence, what this question is saying is if we set the denominator equal to 0, then we will find the x value that makes the entire function undefined. So let's simplify this, okay? So x minus 5 squared, well, that's going to be the same as x minus 5 times x minus 5. So I'm going to just rewrite all this so we can see every single step here. And then I'm going to do FOIL here. So x times x is x squared. X times negative 5 is minus 5x. Negative 5 times x is another minus 5x. And negative 5 times negative 5 is a positive 25. Now I'm going to distribute this positive 4. So that's 4 times x is positive 4x. And 4 times negative 5 is negative 20. And I have plus 4 is equal to 0. So x squared is the only x squared term I have. So let's keep that there. Negative 5x minus 5x is negative 10x. But then I also have a plus 4x, so that's going to be negative 6x, so minus 6x, so all that's gone. 25 minus 20 is 5, plus 4 is 9. So x squared minus 6x plus 9 equals 0. That can be simplified even further into x minus 3 times x minus 3 is equal to 0, which of course means I can write this as x minus 3 squared equals 0, which means I can square root both sides, leading me, and I'll just get some more space over here, to having just x minus 3 equals 0, and I add 3 to both sides, giving me that x equals 3. So when x is 3, it makes the denominator equal to 0, and whenever you have a denominator equal to 0, it makes the entire fraction, and in this case, the entire function, undefined. So our answer here would be 3. So guys, I hope you enjoyed this 20 minutes of review. It is literally every question on test 1 that utilizes the strategy Simplify. If you like this, please leave a comment. Please like the video. Please share with your friends. I would love to go through every single test that's out there, with simplification, with plugging your own number, all the strategies that I teach, just to show you, first of all, me answering these questions in a little bit faster pace than what you see on my typical videos, where I go in more depth and how to answer each question in much more detail, and that you can see, hey, if I understand this strategy, if I know Simplify really well, I'm going to grab 8 questions, right? If I know this other strategy, I'm going to grab 10 questions, right? So it's really a strategy by strategy mastery that I think is the best thing here. By all means, if you love the video, please do hit the super thanks button and show me your appreciation. Follow, subscribe. I love teaching you guys, and I hope that you enjoy what I'm providing to you absolutely free of charge. I hope that you are, because I love to do it. And I look forward to seeing you on the next video. Take care. Bye-bye.